All right, ladies and gentlemen, I hope we're having a good day out there in the internet land, the interweb. If you're, yes, special shout out to my fans listening in Qatar, especially in Doha. All right. So what are we going to do today? Well, we're going to do a little bit more equations, but mainly talk about inequalities today. Okay. Now I'm going to teach you a new way to solve these logarithmic and exponential equations. Okay, a little bit new way to solve. It requires your calculator, so go ahead and get out your calculator. Now there's going to be not a lot of writing today. There's going to be a lot of calculator work, but not a lot of writing today. Okay? So, let's take a look. Use a table and graph to solve. Now, could I have solved this algebraically? Probably somehow. Yeah, I'd say there's a way to solve this algebraically, but I'm going to teach you a different way. Let's use our calculators to solve that. And when it says use a table and graph to solve, I'm saying use your graphing calculator. Okay. So here's what we're going to do. Now, whenever you have two sides of an equation, you can treat it like a system. Okay, you can treat it like a system of equations, right? Where the left side is y1 and the right side is y2. So let's do that. Let's put the left side of the equation in as y1 and the right side of the equation in as y2. Let me clear out everything I've got there. Okay. So the left side is log of x plus 70. Now, if I ask you to do it in your calculator, I'm going to have to restrict it to only log base 10, right? Because I know there are some of you out there, like me, who cannot do log base anything. I've got to do log base 10 and only log base 10. So log base 10 of x plus 70 on the left side, and on the right side, it's 2 times the log base 10 of x divided by 3. Okay, I'm going to zoom 6 because I'm not sure where my calculator was before. Looks like I've got a straight line, and then that. Now, all right, now, it looks like I just have a horizontal line, but I know better, right? I've got two logarithms. I've got two logarithms, right? So this x plus 70, we'll do that, any logarithm shape, I guess I should start here. Any logarithm shape, this is the general shape of a logarithm, right? What we're seeing here with this flat line is the x plus 70. Here's a little foreshadowing. What do you think this is doing to the logarithm? What do you think a plus 70 inside is doing to the logarithm? Translating it somewhere. Yes. What type of transformation do you think? What adds and subtracts? Up and down or left and right, right? That's just a shift. Is it stretching or compressing at all? No, that would be a multiplication. Addition and subtraction is reserved for the left and right and up and down shift. Now, if it's inside parentheses, is that horizontal or vertical? Horizontal. And it's always opposite of what we think, right? So if this is a plus 70, this is actually probably moving it to the left, 70 units. So you know what we're seeing? We're seeing this part of the logarithm, like way over there, almost making it look flat, okay? Like this piece in here, here you go. Here's a little screen magic. It's probably like over there, right?
YouTube's gonna be confused.
I know you're not. Yeah, they all just whoa, and you have no idea what's going on. Okay, so how do we see it? Let's zoom out. Or let's zoom fit. I'm sorry. Let's see what happens. I see a little bit of an increase now, but do I see the rest of it? No. So now let's zoom out. Because the goal is just to see what's going on, right? Okay. You know what I'm gonna do? I'm just gonna change the window because I know it's got to be shifted 70 units left. Let's just hit window and then go to X minimum as 80. Do I need that big of an X maximum? Not really. Let's put it back to like 20.
Oh, there's that one.
Maybe I should have kept it at 40. Let's keep it back at 40. Here we go. Now, I ask you, for real, do your logarithms stop?
Yeah.
Like mine does right there?
Yeah.
Okay. Okay, now, do they actually stop? No, they don't actually stop. That's where the asymptote is, right? Again, your calculator is a very dumb, smart object. It's gonna, all it's doing is running values and plotting the values. So you know what happened here? It got so close and close and close to nothing that it just thinks it's gonna go away. Okay? That's what your calculator is doing there. We know better. We know that this is gonna continue on down here and continue on down here. Don't be deceived by your calculator. Okay? All right. So where do I want to find out these are going to be equal? The intersection point, right? Do I see it on my screen now? Looks like it. Looks like it's right there. Let's calculate the intersection point. First curve, enter. Now look at what happens when you try to click second curve. Why is it doing that? Well, let me hit second curve. Guess what? Just hit the right arrow. Actually, you know what? It's at, you know why? Because this is at -20 and -12 down here. Where does this, is this logarithm defined at -20? No, you just got to keep arrowing until you get an X value. There it is. You see how it picked up on my trace? Now I'll guess. There it is.
Let's go.
Ka-chow.
You alright?
Chow.
Ka-choo.
We're not fine.
Yeah, stop fighting with it.
Oh my gosh.
You feel good. I feel like there's a dark cloud over that, guys. There is. And it's
Do we need to have a table
shortly.
mention?
Huh?
Table
I think
mention?
if Gavin needs it, then yes.
Yeah, let's start by saying I feel.
I feel. Okay, well, I feel that Lizzie. Calm down. What am I doing wrong?
Table at the back of the room.
We
don't know what's going
We have
on.
fun
Hold
here,
this closer.
guys.
This is all being recorded.
Ah.
Would we like to stop
She
it?
said what? What? Crazy math class. They're like writing us down. Like,
All right, so the answer is just 30, x equals 30, right? Do I care about the 2? No. I don't care where it happens on the y value, I care the x value that it happens at, okay? I modeled it with graphs, but really I was just trying to find the x value. Okay. All right. So what if we change this into inequalities? What if we change this into inequalities? I am not actually finding the intersection point now. I'm finding where it's going to cross and which one's going to be bigger than the other, right? Okay, so let's do the exact same method. Y equals 2 to the x plus 1. Make sure you put the x plus 1 in parentheses. If it's not, I know some of your calculators just put it up there and you have to arrow down. 8,192x. Holy chicken nuggets. I'm going to zoom 6. Okay, there's my 2 to the x plus 1. And where is my 8,192x? You know, think about this logically, right? Think about it logically. I see the exponential function on my graph. What is 8,192x? What type of function is that? It's just linear, right? Where's my y-intercept? At 0, right? It's crossing through 0, 0, so why don't I see it? What's the slope? 8,192, right? So it goes up 8,192 over 1. Up 8,192 over 1, right? So this is an extremely steep line. Like if I really wanted to draw, your calculator just doesn't have like enough pixels to draw it, right? It can't separate the 0 line and this 8,000, like it's right there, right? You know, if I could exaggerate it a little bit. Okay, so let's zoom fit. Zoom 0. Okay, so now I don't see my logarithmic one anymore, or my exponential one. Now I only see. Okay. Yeah. So what are we seeing here now? We're only seeing, like, this is my exponential, right? It's following almost along the axis. How do we make my window the way I want to see it? Would zoom out work? Kind of have to play around with it from here. Oh, zoom out does work. No, I just didn't see it yet. That's why. It must have spaced out the y values. Okay. So I see my exponential and I see my linear. Hey guys, did you know you can turn off your axes? Like, take a look at this. If you go into format, and I know this might look different for you guys than it does for me, I can turn off my axes. Why does that help me within this one? Because there's my exponential, and then there's my linear. So I see it crossing twice. Okay, I see it crossing twice. Now, let me pull this over and get rid of one of these.
Whoa.
See ya. See ya. All right.
That is weird.
Now, remember that this is my blue line, and this is my red line, right? Okay. What do we want to know? So which one do we? How do I state this? We need the exponential to be bigger than the linear, right? Take a look at the actual inequality. The exponential needs to be greater than the linear. 2 to the x plus 1 needs to be greater than 8,192x. Now, what needs to be bigger? Does that mean to be like more to the right side or more up? What does that mean? Well, think about this. We put this in as y1. We need to know when the y's here are going to be greater than the y's here. Now, what makes a y value greater? What constitutes a greater y value visually? What constitutes a greater y value? When something is higher than it, right? When something is more vertical than it, right? So that means at this point onward, that's when the exponential is on top of my linear. From this point onward, that's when my exponential is on top of my linear. What about all the pieces in here? No. All those pieces in there are below my linear function. So we just need to figure out where those things happen. Let's calculate some intersection points. Come on, calculate intersection point. Okay, so there's one of them. Where's the other one? Second, calculate, intersect. Now I just have to hit my guess closer toward the other one. Okay. Those are my two intersection points, right? So how do I write that out algebraically? Well, we say we want when x is going to be less than, because it's to the left of this, right? To the left, every x value to the left. X is less than 0.244 times 10 to the negative fourth. Oh, we could do that. 0.244 0, 0, 0, 2, 4, 4. Or x is greater than 16. Why is this an or? Because it points out, right? If I were to just flatten this out on a number line, it would look like this. Here is 0.000244, and then here is 16. All x values to here, all x values on that side as well. Okay, but this is my true answer then. Okay? Let's try another one. Yes?
My line is just straight across. Like it's just, instead of yours, it goes up to the right, and just goes straight across.
Okay, let me look at it here. Why don't you guys start trying this one?
Mine goes like a line, just straight across.
Let's do this. Zoom. Go back to standard. You go up.
Oh. Now zoom out.
I zoomed this. I'm sorry, I zoomed this.
Oh. Okay.
And now I zoom.
Why did I do that? Is it just a?
It's a combination of how you zoom it.
Alright, thank you.
Yep.
Our calculator. Oh, it's just because it makes the one axis work.
Oh, I forgot to turn my axes back on.
We were seeing it in that second.
Okay. No. Turn my axes back on. I regraph real quick.
Whoa.
Okay, so I see my 2x, 2 to the x, and then I see 4 to the x minus 1 come in. Okay? Okay, let's calculate that intersection point. I think I see everything that I need to see on this screen. I don't even need to zoom fit, I don't think. I'm going to calculate the intersection point. And it comes out to be at x equals 2, right? Okay, now, are they going to cross again? The other one crossed twice, but that was just because we had an exponential and a linear. Are they going to cross again? Well, if I were to look at my table, go to your table. We know the critical point is at 2, right? And at that point, y1 is on top of y2, right? Once I get to the left, you know, if I want to over-exaggerate a little bit, if this is my blue line and this is my red line, right? It drops below. The red line drops below at that point, right? Okay. Now look at my table. I want to know if it's going to cross again. Keep going up in your table. Is the y2 always going to stay underneath the y1? Keep going in your table. Like you could go forever and ever and ever and ever and ever. Is y1 ever going to catch up to y2 in terms of going to cross again? No. Oh, really? Good luck with that. And that's the idea of an asymptote. They're going to decrease at like the same rate underneath it. Okay. So we can say no, that they are not going to cross again. So we need to figure out, okay, is this an x is greater than 2 or is this an x is less than 2? Well, think about it on a number line, right? Here's 2. Do I want points to the left or do I want points to the right? Well, if I say I plugged in 0, I mean, we could just pick a test point. Heck, let's pick a test point. What happens at 0? Well, this turns into 1 is greater than 4 to the negative 1, 1/4. Is that a true statement? Is 1 greater than 1/4? Yes. So I know that this is true, right? So we say x is less than 2, okay? Or you could say, you know, graphically looking at it, when does this happen? When does 2 to the x get higher than 4 to the x minus 1? When is it on top of 4 to the x minus 1? Here. Let me like outline it purple here. Here, right? That's when it's on top. What x values make that happen? Any x value less than 2. Any x value bigger than 2, then it would be bigger, and it would be smaller. Okay? What are these? Nah.
Whoa.
Nah, we're good. All right, that's where we're going to end today. Homework is up there on the board. I know, like, did you write anything for notes today? I don't think so. Calculators. Notes for today is calculators.